So good evening, everyone. So this is the discussion session for Track-2, which is on short-term energy load forecasting. So what we are going to discuss is we are going to introduce this competition. I think you might have already received a link to the Kaggle competition, and then you might be already familiar with or going through the data set or familiar playing with the data set. But so we would like to formally introduce this competition, data set details, and what are the things you can try as part of this competition. So today, with me, I'm Dr. Arjunan Pandarasamy from IISc Bangalore. So with me, Pankaj and Subodh are joining from IBM Research Lab. Okay, so the agenda for this discussion is we'll just present the overview of the problem, which is short-term energy load forecasting. And then we'll walk through the data set and we'll introduce what are the fields and attributes available in this data set, and then how we can play with this data set for developing energy forecasting models. And then we'll also explain what all the generative AI based forecasting models are available, particularly the time series foundation models, how one can leverage these models for solving this load forecasting problems. And then we'll end this session with question and answers. Okay. So just to introduce and motivate the need for this problem. So as you know, so we have a very complicated electricity grid. So where we have a lot of generation systems, which include solar farms, wind farms, coal plants, hydroelectric dams, and then we'll have smart grid, which consists of transmission and distribution system. And then finally, we'll have customers, which is like different industries, buildings, which include commercial and residential buildings. Okay. If you look at the buildings sector alone, which includes commercial and residential building, so they account for 34% of total energy consumption. And then this is the rough number, which is more or less similar in other countries also. And they are also contributing about 25% of greenhouse gas emissions. And within this building sector also, we have up to 20% of loss due to various reasons. Okay, so maybe because of inefficient use of electrical appliances, or somebody forgot to turn off some appliances when they are not in use. Okay, now how are you going to solve this problem, right? So because if we can reduce the energy usage from this building sector, we can kind of make the grid more reliable, and we can reduce the energy consumption, and we can also minimize the emission from this buildings. Okay, of course, to solve this problem, we need data. And quite recently, so various utility companies, they started installing something called smart meters, which is part of a big initiative. It's called advanced metering infrastructures. So what does that mean is actually typically in your household, you will see a electrical meter, right? And someone from the utility company, they'll visit your meter, and then they'll take a reading on a monthly basis, and then you'll get a bill. Okay. Of course, there are portals and mobile apps available through which you can see the consumption patterns, but the resolution is mostly monthly basis. Okay, so every month how much you have consumed. Okay, and this consumption pattern also will vary over that time. Okay, so typically summertime the consumption will be higher. Okay. So what the smart meters bringing into the solution is actually, so they can measure the electricity usage instantaneously. So typically like every 15 minutes to 1 hour it can measure, so that we'll have a fine-grained energy usage from individual buildings. Okay. So for example, in India, of course, this kind of smart metering infrastructure is being implemented across the world. But if you look at in India, so this is mostly handled by National Smart Grid Mission, and they have already installed close to 2.4 crore meters, and they are going to install such meters in other buildings. The point is, this kind of high resolution smart meter data can be used for better managing energy usage in buildings. Okay, so one of the tasks that you're going to solve as part of this competition is energy forecasting. Imagine, okay, so if you are able to forecast for the next day or the next month, then you can plan the energy consumption in your buildings. Okay, so individual buildings also you can plan, and for a group of buildings like a community also you can plan, or at the city scale or even national scale you can plan. Okay, so this kind of planning can be done by using this smart electricity meter data. Okay, let's see how does the smart electricity meter data will look like. Okay, what you see is actually an hourly electricity consumption from a building. This is actually called a heat map. In the x-axis, what you see is actually day of the year, and then the y-axis you see the hour of the day. So each cell corresponding to a particular day and hour indicates how much energy was consumed at that particular hour. Okay, as you see clearly, you see a clear pattern, right? So this is actually an example of a school building. So the school seems, start opening at 6 o'clock. That's why, from midnight to 6 o'clock, there is less energy consumption. So which is denoted by this dark blue color. In the right hand side, you can also see the energy consumption. Okay. And then throughout the day, from morning 6 a.m. to 6 p.m., the building is consuming some energy, and then they are turning off appliances, or they're turning off all other operations in the building, and the night time there is less energy consumption. And then in between also you see this vertical bar that indicates actually the holidays or the weekends. So there is less energy consumption during this. Okay, as you see, this is actually a very clean building which follows a consistent usage patterns. But of course, based on the building's operational pattern or other characteristics, these kinds of energy consumption pattern will vary. Okay, so for example, in this building itself, you see because of the summer time, July and August, there is less energy consumption compared to other days. Okay, interestingly, if you notice that around in the month of June, there is high energy consumption during the night hours compared to other buildings. This could be a anomaly. Maybe some event happened, or they might have forgot to turn off some appliances. Okay, so these kind of patterns you can see by analyzing the smart electricity meter data. So as part of this problem, what you're going to do is actually, so you're going to focus on short-term energy load forecasting problem. So what is the goal of this problem? You wanted to predict the next day's hourly energy consumption using 1 week of historical data. Okay, so what you see is actually the observed data. As you see, this is a clear pattern. So you see this clear pattern because typically, the daytime there will be high energy consumption, and then nighttime there will be less energy consumption. Okay, again, this kind of fixed pattern you can see in commercial buildings, but residential buildings, this kind of there will be a lot of variations, because a residential building there may be like elder people or somebody else will be using the buildings. So the patterns is very complex. Okay. So as I said, the goal is actually using a 1 week of hourly data, which is 168 readings. You have to forecast for the next 24 hours, which is 1 day. Generally, this is called the forecast horizon. In our case, the forecast horizon is 24. Okay. And this is for one building. Okay, so this is the website for the competition. So you can find these details, basically the problem statement, what is the objective of doing this, and what are the models can be used to solve this problem. Okay, so imagine if you can develop a better energy forecast model for like a many buildings, like millions of buildings in a city or millions of buildings in a country. So all this collective information can be used for the better planning of electricity distribution, and also it can prevent energy losses in the system. Okay, so next I'll walk you through the data set that we are providing as part of this competition. So we are providing 3 subset of data sets. The first one is called the train.csv. I think all those details are there in the Kaggle page. Okay. Okay. So the train.csv contains 5 columns. The first one is called building ID. So this is a unique identifier for each building. Okay. So I think we have close to 100 buildings are there. So you'll see a running number for this attribute. And then we'll have something called window ID. I'm going to explain that. Basically, we are defining a window as 8 days of energy consumption pattern. So which includes the first 7 days of historical data you are going to use, and the next 24 hours of data that you need to model or you need to predict. Okay, and then you'll have a unique timestamp. So this is in the ISO 8601 format. So year, month, day, followed by hour, minute, and second format. Okay, and then you'll have the meter reading. So this is the electricity consumption at that particular time. Okay, so this is in the unit of kilowatt hour for the particular building and hour. Okay, and then you'll have something important. This is called a role that indicates whether that particular reading belongs to a context or the historical data, or that's the forecasting. Okay, so generally you'll contain 2 values. This is the source or the target. Okay, I'm going to explain how does the data will look like. Okay. So consider one building. Okay, so one building, so let's say you consider like a one window. So one window consists of 168 points. and then the roll of this first 168 points will be input, and which is followed by 24 points, which is denoted as this target. Basically, in our training data set, we are providing data for input and the target together so that you can build your models to learn the pattern from your input so that you can forecast for the target. Okay, so likewise, you have a unique window identifier for each building. Okay, now remember that this is a rolling window, so we are moving this window one day at a time. Okay, so the first window will contain from day 1 to day 8, which includes first 7 day for context, and then the next 1 day for the target that you need to forecast. And then the window 2 contain day 2 to day 9. Okay, day 2 to 8 for historical data, and day 9 for the prediction. Okay, so and so for individual buildings. Okay, since we have multiple buildings, now this is what you'll see, right? So there will be a unique identifier for building. Okay, and then for each building ID, you'll have multiple windows, and then within each window, you'll have energy consumption readings for input and the target. Okay, this is how we are the hierarchy of data is defined. Okay, so similarly, you have test data sets. The only difference is that so you won't be having any meter reading for the target buildings. Okay, so otherwise the attributes are same. Okay, so you'll have unique building ID, and then the window ID, and then the timestamp, meter reading, and role. And the role again, it will indicate whether that's the input or the target. Only for the target readings, the meter readings will be empty. So that's what you need to predict. Okay, so remember that the training data set, the type of buildings are different, and the test data set, the type of buildings are different. When I say type of building, the building identifiers are different. Okay, it's not like you are going to learn from a particular building and then you are going to forecast for the some other energy consumption, period in the same building. Okay, these buildings are different sets. Okay, so that also you have to keep in mind. Okay, so by the way, to give some additional context, this meter readings comes from utility company from Pune, and we have also given some additional metadata. So that includes the city information, so that also you can use for better forecasting. Okay. In addition to the metadata, we also provide metadata. So basically, there are some contextual information about each building or some attributes, so which can help us to better, develop a models. Okay. For example, in a typical building, the energy consumption pattern is, affected by multiple factors, right? For example, the building size, the type of appliances being used in those buildings, the location, all these attributes are influencing the building's energy consumption. So that's why we provide all this metadata. So this also you can use as a contextual variable when you are developing your forecasting models. So this contain like a various attributes. I'm just listing only a few attributes. So again, this building ID, which is an unique identifier. Remember that this is the key across your training data set and the test data set. This region indicates the geographical region where the building is located, basically the city name. I think we have 5 different cities. Okay, the rooms indicate what is the total number of rooms in that particular house. Okay, and then other information like number of people's, number of residents in the building, what is the size of this building, and then details about whether these buildings or these households uses a specific type of appliances like air conditioner, washing machine, refrigerator. So all those informations are provided in this metadata. So the task is actually you have to using the training data set, you have to train your model, generative AI models or other types of models, so that you can understand the patterns of energy consumption by looking at the historical energy usage patterns as well as some of this contextual information or this metadata. Okay. And then after learning your model based on this training data set, then you have to test your models on the training test data set. Okay. So of course, in the leaderboard, we'll have 2 types of leaderboards will be there. One is called a private and another one is the public. Basically, the public leaderboard will get updated as and when you are making a submission. And the private leaderboards contain some unknown building, which is not part of evaluation when you are participating during this competition. And the private leaderboard will be released after the completion of this competition. So any questions so far? Yeah, so any questions so far? Okay, if there are no more questions, then we'll proceed with explaining what kind of modeling techniques we can use. So Pankaj, can you take over from here?
Sure, Professor Arjunan. Thank you. Yeah. So
So in
I'll
fact, I
request.
have merged the slides. If you want, I can navigate through different slides actually.
Okay, you did merge, right? Okay, good,
Yeah.
good. So yeah, so thanks, Professor Arjunan, for covering this data set and the competition details, right? So in this part, right, what we'll try to cover is for all the students who have joined, provide them brief background of, I guess everyone has joined, so they are aware of time series. But okay, what is time series? What is multivariate time series? And also, there's a lot of work happening recently in time series foundation models. So we'll talk about a few time series models that IBM has developed, and also some of the other models that are available, right? State-of-the-art models. And at the end, Subodh will also take you through a sample boilerplate code that could be a good starting point for the teams, right, to start using some of these models, right, for this forecasting task. So time series, anyways, is a sequence of point that occurs at a regular interval. And one of the things that Professor briefly mentioned was that there are a lot of other data that is available in terms of metadata and city information, other things. So you may also want to look at some of the other time series, weather-related time series, because many a times it's better to look at this problem as a multivariate problem because the value of, let's say, the energy consumption may not just depend on the historical value. Let's say the red value, red series over here is the energy consumption data. But the value for future may not just depend on the past values of energy consumption, the red points, but also may depend on some of the other exogenous variables or other time series, right? So that way, maybe if you may want to not just look at a univariate time series, but also look at the multivariate aspects, right? And the focus of this hackathon is on smart meter energy forecasting data. But in general, you would encounter such problems and the various applications in different domains, right? Starting from industrial domain to energy forecasting to retail and supply chain and so many domains, right? So that way, I guess these models are really at the core of time series analysis, and use of this model is at the core of enterprise operations, right? Yeah. So move on to the next chart. And if you look at how things have evolved over a period of time, right, in machine learning and AI. So initially, all this started with rule-based system where you had certain sets of rules based on which you do some inference. Then we moved to machine learning era where you had task specific, you did a lot of feature engineering and built your models. To era of deep learning where you had massive amount of labeled data, compute was available, and then you had for each task you have built different models, right, using this huge data and huge compute. To 2018 onwards, then there was transition to this foundation models. Initial research started where you had self-supervision because a lot of unlabeled data was available. The idea was how to use this unlabeled data to do something, a self-supervised model. That was the foundation model. And then you could do various downstream tasks, right? So using the same common foundation model, right? So a lot of research started there, and then 2022 onwards, as everyone has played with this, then the boom of this LLM GPTs where people started using it at scale, right? So there was some lag, but I mean 2023 onwards, similarly, a lot of research, 23, 24, a lot of research in time series also started where people started developing this pre-trained models using both time series data and also extending the language models for time series domain, right? So a lot of work that also happened at IBM in our group was on patch TS mixer, patch TST. These are some of the architectures, and TTM is a pre-trained foundation model from IBM, Kronos, Moira AI from Amazon, and Salesforce. So likewise, a lot of models from a lot of research started happening there. And from last 2 years, you see a lot of boom in terms of use of these models for various applications, right? And uh, different areas and domains. Move to the next chart. So the key question is, okay, you can use language models also for tokenize and use it for predicting the next token. So you can model time series also in that way. But why do we need a separate model for time series? There are various unique challenges when you encounter when you look at time series data. And for example, at a high level time series, you may each word when you look at a sentence, there may be some semantic meaning there associated with the word, right? And that more or less remains the same. It's you read that across different contexts. But in time series, value for a given time step, let's say it's 10, that doesn't say convey anything about what's happening in that time series, right? So you need to look at something before you need the context, right? Based on that, what the value you can basically interpret what that value uh, conveys, right? Similarly, time series, you as I discussed in the previous chart, the multivariate in nature, and it can be you have correlation across time and across series as well. And one important thing is this data is available across different industries. When you want to pre-train a model, you and get data from various industries, this would be available at different resolutions, sampling rates, seasonality, and things. So all those poses very unique challenges when you want to build a foundation model, right? And a lot of data is not even available, public data sets. So that's where there are a lot of challenges, and but it's crucial, right? It's important that instead of using the language model, maybe working with something from time series specific to time series does provide additional this thing, right, improvement in terms of performance. Moving to the next chart. And yeah, one last step before I hand it over to Subodh is when we talk about multivariate time series, and this would be useful as you work on this specific problem, is that there are some variables or some variates that you want to forecast. So we call all of these as channels. So some channels, in this case, target one, target two, are the channels where you have the historical context. Prof said maybe for 7 days data is available and you want to know the values for next one day, right? 24 data points. But there are some things which are like exogenous to the system, right? Where you may not be interested in forecasting, but the values of those channels would be useful for you to get an accurate, for example, weather related, let's say temperature in a city, right? So if you have historical data about how the temperature varied in last 7 days, and also you have some good forecast for next day or so, what would the temperature look like city, then that information would be very useful for you to include that while forecasting your, let's say, the energy consumption, right? So these are exogenous variable, then control and conditional. Maybe for this hackathon, this may not be relevant, but in general, right, having a model that can support all these type of variables when you generate the forecast, right, capture all these correlations across these variables would be important. And that's where I guess in the boilerplate code also, when Subodh covers, we'll talk about one of the models, that is tiny time mixer from IBM. So that's also first of a kind model that supports all these variables, right? When you want to do multivariate time series forecasting, right? Next chart. Okay, so maybe Subodh, you can take over and cover a bit more details, and
Yeah,
then
sure.
we'll get into the code after
Sure.
that.
Thanks,
Any
Pankaj.
questions? Just let me pause for a minute. Let's see. Initial part, both the competition description data set and initial part, if there are any questions. Okay, if there are no questions, then yeah, Subodh, you can continue. Yeah.
Yeah, sure. Thanks, Pankaj. Thanks, Professor. Yeah, so I'll be covering a little bit in detail about the, let's say, the architecture of these foundation models, and I'll go in a bit detail about the group of models that we have, group of foundation models that we have here at IBM Research that we have developed. Pankaj briefly covered about the task specific models and how we transition to the era of foundation models, right? And this has been consistent across all different domains, whether it's vision, language, and similarly for time series. So we can see all these methods and models into broadly two categories, that is like the pre-foundation models, pre-foundation models era, and the foundation models. So as before foundation models, these were all like task or data specific models, like which were trained end to end on a specific domain, right? For example, it can be trained on a data from let's say some finance domain or energy domain, and then it is used on the same domain data, right? So the benefit of this is that it generally leads to a very good in domain performance, right? But it comes with a limitation that there is a very limited generalization. What does that mean is, let's say if you have trained a model on some domain D1, then it's probably not going to work very well on some another domain, right? If you just want to use it out of the box. And these models fall under two different categories, like statistical models, and then we move to like deep learning based time series models, right? You might have heard some of the names like arima, prophet, which are statistical models, and then some of the common names in deep learning models are like patch tst and ts mixers, which are based on the transformer architecture and the mlp mixer architecture respectively. So yeah, next slide, please. So yeah, now I'll talk about the time series foundation models. So as you can see in the diagram, as we move on from the task or data specific models, what we do is basically we collect the corpus of data from multiple domains together, right? And the idea is to train a single model that can perform well enough on all these different domains together, right? So that it can provide out of the box zero shot capability. So zero shot capability means just you can take a model that has already been pre-trained on huge amount of data and can apply it on any domain, whether it's a weather domain, or finance, or whatever domain, and hopefully the model uh, can generalize well across all these domains without any further training. But it might be the case that the data you want to use the model on is pretty different from what it has seen during its pre-training, right? So sometime it all these foundation models, they need to be tuned on your domain data a little bit so that it can perform well enough. Yeah, Professor, go ahead, please. Yeah, so this is just pictorially how does a general flow of training time series foundation models look like. So there is just a huge corpus on which we pre-train a time series foundation model, and then we can use it in zero shot or few shot fashion for inference on our target test data, right? Yeah, next slide, please. But there are some challenges that comes up with these foundation models, right? So the first challenge that comes up with these models is the model size. So since they have to learn a lot of pattern so that they can generalize well across different domains, generally the number of parameters that these models have is pretty high, right? It can range from few million parameters to few billions of parameters, and consequently it leads to higher inference time, which because of the high number of parameters. And as a result, extensive compute power is needed to even infer from these models, right? You may need multiple gpus and significant amount of time even for zero shot forecasting, if you are going to use some models having some pre-trained foundation model having a billion parameter. So next slide, please. So this is where the group of models comes from our research team here at IBM Research, where we have released a couple of foundation models that are very lightweight, right? So maybe to start with, I'll just start with patch TST. So basically, patch TST is a task specific model. It's not a foundation model. It's a backbone, or you can say an data specific model that you can train on a single data and use it on that particular domain. And it's transformer based architecture. Then we released patch TS mixer, which is also not a foundation model. It's a backbone architecture that is based on MLP mixers, right, which are very lightweight as compared to the transformer based architecture. Then last year we came up with TTMs, which refers to tiny time mixers, right? And they are foundation models that is developed on the patch TS mixer architecture. So TTM is a set of models, very lightweight models, even having less than a million parameter, right? So which is first of its kind lightweight foundation model for time series forecasting. And very recently, we came up with TS Pulse, which enhance our capability from just for time series forecasting task to other tasks like anomaly detection and imputation or classification, which are equally important time series tasks, right? And again, it's our lightweight, very lightweight foundation model with having only 1 million parameter and is based on the patch TS mixer architecture. So all these models are currently open sourced on like Hugging Face, where you can directly download it from there and use it out of the box for your task. So next slide, please. Yeah, I'll highly encourage if somebody wants to, go deep dive into how these models are pre-trained and what's the architecture of these models, what's the evaluation metric, etc., and how do they compare with other models, to go through the research paper that we have published. Yeah, next slide, please. So yeah, regarding why TTMs are one of the best models or one of the models that you should try for your task is, as I mentioned, right, a lot of foundation models are for time series are built on the transformer backbone, and as you know, the transformer built architectures generally tend to have a lot of parameters. So in this particular slide, I have mentioned a table where we compare the number of parameters. So the first row mentions it corresponds to TTM, which and then it shows the GPU inference time, the CPU inference time, and number of parameters a particular model have. So the first row is TTM, and we basically compare it across multiple other foundation models that are out there. So you can see the number of parameter is like well below 1 million, right? And if you just compare it with some another foundation model like Chronos Large, which has around 709 million parameters, right? So which is more than 800 times larger as compared to TTMs. So the TTM is, as I mentioned, based on lightweight TS mixer backbones, which are nothing but just a stacked layer of MLP mixers that mix the time series patches that goes through the model across 3 different dimensions. The first is like the interpatch dimension, the second is intrapatch dimension, and the last is like the channel dimension, right? And the best thing is that you don't need a GPU to infer using TTM models. They are very lightweight and they can even run on CPU on a laptop. Next slide, please. So, but then a natural question comes up, right? Whether these models, if they are very small, do they generalize well, or in zero-shot setting, right? How do they compare to another models having significantly high number of parameters, right? But as you can see, like the TTM models are, although very lightweight, but they still are very competitive and often outperform other very big time series foundation models, right? So for example, it performs 32% better as compared to like Chronos, which has like 8 million parameters. And we have benchmarked the CPU inference time. So you can see the CPU inference time of other foundation models are like multiple times higher or multiple magnitude higher, right, as compared to the TTM inference time. Next slide, please. So I'll not go into any more architectural details. As I mentioned, you can go to the research paper and read in detail about it. But all these models, all these TTM models, they are currently open sourced on the Hugging Face. All these pre-trained models are available there, and they support a wide range of context lengths that you can try these models on, like ranging from as low as 52 to as high as like 1500 input length. And similarly for the forecasting length, it can support forecasting horizon of up to 720 points in future. And all the public code to get started are available on our Granite TSFM repo, whose link we will provide at the end of this presentation. Next slide, please. Okay, so these are this was about the forecasting task and the forecasting foundation models that we have, that is like TTM. But as we mentioned, right, for apart from forecasting, anomaly detection is one of the tasks that that can help in this particular track that we are going to work on in this hackathon. So forecasting is a straightforward task. For anomaly detection, basically it means to identify deviations in our time series data compared to the general pattern that the data is following, right? So for example, in the shown time series data, you can see it follows a good seasonal pattern, but in the mid there is a huge spike, right? And most probably this particular spike is some kind of anomaly, maybe some sensor failure or some some incident that's not expected. So there can be different types of anomalies, for example, point anomalies or contextual anomalies, and there are different methods to handle these anomalies. But as we mentioned, right, the foundation models are supposed to work for different variations together, right? So I'll mention about the model that we have. And yeah, regarding the application of this time series anomaly detection, they are widely used for tasks like fraud detection or predictive maintenance in an industry where, let's say, there are multiple sensors recording time series data, and you just identify some unexpected behavior in a particular sensor, and that can be used for maintenance of predictive maintenance, right? So next slide, please. So as TTMs are foundation models, lightweight foundation models for time series forecasting tasks, we have recently released a set of models, TS Pulse, which basically is there for multiple tasks, right? As I mentioned, for anomaly detection or classification. But for this particular track, we have this particular model can be used for tasks like anomaly detection. So again, you can read more about this particular model on our paper. Next slide, please. Yeah, as I mentioned, TS Pulse is also based on lightweight MLP mixer architecture similar to TTM, but it has been pre-trained with a different kind of loss function and a slightly different architecture to make it accelerate in different tasks like imputation, anomaly detection, and classifications, right? And despite being like just 1 million parameter model, it significantly outperforms other state-of-the-art pre-trained models on all these different tasks. So next slide, please. Yeah, similar to TTM, TS Pulse is also released on Hugging Face, where you can download and play with all these different TS Pulse models that are out there, right? And again, the modeling code and inference code is available on our public Granite TSFM repo. where you can use this where you can get this model from and use it directly for your task, or maybe fine tune it on your particular data and use it. So next slide, please. Yeah, so you can refer to these different links where all these model codes and the model weights are out there, and you can use these different models for this particular hackathon, or any other domain where you want to do time series forecasting or anomaly detection tasks.
Just
So
one additional point, right, Subodh? Yeah, there is also beyond the hackathon also, right? If any student is interested in contributing to the architectures or using these models, creating some applications, then there is this global remote mentorship project for this time series foundation model that we have floated. So any of the students, if they are interested, can apply for this, and if yeah, a good match, then I guess you'll get to work with Vijay Ikambaram, so who is the technical research lead who has been working on this TTM and TS Pulse model, right? So yeah, he will be mentoring any student who, if he is interested in contributing to some of these models. Yeah.
Okay, thank you. Thanks, Pankaj. So now I'll be walking through the demo code that is out there that we have, released on Kaggle. You can find it on Kaggle, where I have showcased a demo notebook that uses the pre-trained TTM models for the task at hand, right? So maybe Professor, can you share the notebook, or should I share the notebook and go through it?
I think you can share the notebook.
Sure, sure.
Okay, I'm going to stop sharing here.
Sure.
So any questions so far about the competition and the data set and how to use this time series foundation models? Yeah, I think you can share your Kaggle screen and walk through the code.
Sure. Just give me a minute. I think. Okay. Yeah. Is my screen visible?
Yes.
Yeah, sure. Thanks. So I'll be walking through a demo notebook that's available in the discussion tab of the Kaggle workspace. So you can go to this particular notebook that we have created, and it basically shows a demo. It's a demo notebook that shows how to get started with using a TTM model for this particular task. So we start with installing the Granite TSFM library, which is nothing but our public Granite TSFM repo, right, which holds the modeling code and inference code for all these TTM and TS Pulse foundation models. So you can just get started with installing the Granite TSFM library, and it will install a bunch of dependencies. And then it will just import few modules from the TSFM public folder, right? And we basically specify the timestamp column, basically the column which store the timestamps in the data set, and the target column. So basically target column is the column which you want to forecast. In our case, it's going to be the meter reading column. And then we just mention the context length and the forecast length for the model that we are going to use. So in this example, I am using the 51296 model that is out there. So you get your data set and read it from there. And then this is some visualization of how, I think professor also has shown this data, right? So this is how some random samples of this particular data set looks like. And now how to use the pre-trained models. So basically, we start with setting up the zero-shot model that is out there, right? So it's pretty easy to get the pre-trained model from Hugging Face, right? So you just have to pass the path of these models, and the revision. Basically, revision is nothing but the particular model that you want to use. For example, here main refers to the 51296 model, but you can mention any other context length like 18060 or 1500 or 512 360, right? Any context length, forecast length model you can pass in the revision, and it will get that particular model from Hugging Face. Then we create a time series processor. So column specifier basically is just a dictionary which mentions these particular things like the timestamp column, the target columns, and you can also mention other columns like control columns, right? Which are going to be the XOG variables, right? The metadata that we are providing along with the meter reading data. So you can use all these different things that you can specify in the column specifier. Then we just create a time series processor. So basically, time series processor is nothing but a module that basically do a bunch of things like standardizing the input data frame and then scaling the input data. So we define a time series processor, and then it's pretty straightforward. We just have to define a forecasting pipeline, right? So this forecasting pipeline is nothing but a inference pipeline where you can pass your zero-shot model, and you can pass your time series processor. So this pipeline is defined, and this pipeline is just used for inference. I'll just show how to use this particular pipeline. So what in this particular cell, what I'm doing is just iterating through all the different windows that we have to forecast on. So I'll just get the Windows ID and iterate through all these different windows one by one. And we'll be passing, so this is where we pass the window data frame to our predefined pipeline. And yeah, we get a forecast from the as output from the pipeline that we can just keep on appending to our submission file. And as you can see, it's pretty straightforward to do a zero-shot modeling using TTM, right? You just have to define a zero-shot model and create a time series processor and just define a pipeline to pass this your data and the model, and you will get the zero-shot forecast as output of this particular pipeline. So this is just the zero-shot forecasts, but there are a lot of things that you can do on top of these demo notebook, right? That to boost your scores, to make the model very good on this particular data. For the one of the thing is, of course, the fine tuning of the TTM model, right? So the TTM model is just pre-trained on a lot of different domains together, and it might be possible that although it's doing a pretty good job on this particular data, but it can further be improved by fine-tuning on this particular energy data that we have at hand, right? So we have provided a link to a cookbook notebook that you can use to which basically walks you through how to fine-tune a TTM model on any kind of data having XOG variables. So we encourage you to go through this notebook and get your hands dirty on and use these different models to fine-tune and boost your scores, forecasting scores, right? And then in the end of this notebook, we have provided all the necessary links to our public repo, the TTM model code, and Hugging Face repository links that you can go through. So yeah, this was a walkthrough of the demo notebook, and please ask any questions if you have regarding anything till now in this talk.
Okay, thanks a lot, Subodh. Yeah. So yeah, to the participants, if there are any questions, yeah, any doubts regarding data set, competition, anything, feel free to ask.
Yeah, so I have opened the floor for asking the question. So if the participants want to ask questions directly, they can raise a hand and they can unmute themselves and ask the questions. So on the chat Q&A, there are a few questions.
Try to answer, but okay, is there something left? Okay. Q&A, okay. Okay, what is the deadline? When is the deadline for this submission? So deadline is 15th September. Besides accuracy, will factors like inference speed or efficiency also be considered? Yeah, right now leaderboard, everything is yeah, based on accuracy. So I think that would be important.
I think there is another question related to data set from BESCOM.
What is that question? I'm just trying to understand that. For working application, we need to get access from BESCOM too, since we are students. Can we share our final update for drive without the access of BESCOM data? Okay, if someone wants to unmute and clarify, I mean, I didn't completely get the question right. So you're saying BESCOM data is available for what? Sorry, the data set, everything is provided here, right? Data set, metadata, everything for smart meters is provided, and that is what you are supposed to use. Top of that, if you want to combine with weather related variables or something else, you feel free to do that, right?
I think I see a hand raise, so maybe somebody wants to clarify.
Okay. Who has raised the hand? Sandeep Reddy. Yeah, Sandeep. You can unmute yourself and yeah, go ahead. I'm not sure whether he's able to unmute.
Yes.
Yeah, Sandeep, you are audible. Go ahead.
Sir, today we talked with an BESCOM electrical engineer. He said it requires data from their side to display uh, units consumption, data forecasting. For that, for their end also, we required permission. They said like that.
No, so here whatever is there, the data set is provided, right? So the smart meter data.
Sir, we are going to prepare an real-time application instead of existing one.
Okay, but hackathon scope is for this existing, there is water training data. You can use water additional data also if you get from BESCOM, it's fine. But finally, hackathon scope is that on the test data set, the model that you fine tune and build should perform well, right? So yeah, if you have additional data that you want to use, maybe yeah, go ahead and use it, right?
Thank you, sir.
Yeah. Yeah, you can use it for fine tuning the model and then yeah.
Are there any other questions from the participants?
Yeah, we have 2 more minutes. Any last final questions?
In the meanwhile, I have one announcement related to the hackathon workspace, the Kaggle competition. So what had happened was that some participants did not receive the invite to Kaggle workspace because their details were missing in the registration page. That means although their teammates received the invite, they didn't receive it. So that's why we sent another announcement asking the missing details to be filled in a Google form. I hope those who couldn't access the workspace Kaggle invite have filled in the correct details, and we'll be sending out invite again, but you can still use the same invite that your teammates have received and join, because we have already updated the Kaggle's data, the competition data. We have added your name, so you should be able to access now using the invite that your teammates have received. If you are not able to still access the Kaggle workspace, check which account you are using. You should be using the account that you have filled in the form about in the field, the Kaggle registration form, not necessarily the same user ID or email that you use for the dev post registration. And if you are still not able to access, then please drop us an email at admin@cnihackathon.in and we'll resolve the issue. And this is for all the participants or the teams who have received a notification saying that their project has been accepted. If your project has not been accepted, then you won't be able to access the Kaggle workspaces.
Okay, I see one more question there. Sorry, there's on this. There's someone posted whether zero-shot submission using Granite TSFM be valid, or is fine-tuning necessary to score form. Zero-shot submission, you'll get the default score, right? So anyone, I mean, everyone will get the same score if they use a zero shots model, get forecast in a zero-shot manner, right? Using Granite TSFM. So in order to improve your score, I think you'll have to do something with the metadata that is provided, some other data source, and then fine-tune the models. So that's where all the innovative ideas you would have, I think you would have to play with the model, tinker a few things, and then see how you can improve the performance further, right? Yeah. But yeah, it's a valid submission, just that whether it will be may not be take you to the top of the leaderboard, right? Are we allowed to use external data sets in, for example, pattern history? Yes, you can definitely make use of external data sets from different domains if you want to fine tune the model. Yeah, you can use that. Professor Arjunan, any word of caution for this data sets that can and cannot be used?
So we don't have any restriction, except that you should not hard code anything. Okay, in case, yeah. Again, you had to be a bit cautious with the type of metric that we are using. Okay, of course, the choice of model, all those things are important. So you can explore. Of course, the IBM has very good models. TTM, they can do zero shot, and then you can fine tune those models. Of course, you can try some other models also. Yeah, but as such, we don't have any restriction on data set. So what you can do is we provide the metadata, right? So that's what crucial. So you can fine tune our models by leveraging the metadata so that it can help you to improve the forecasting performance. So by the way, there is a discussion forum within Kaggle itself. So there we have posted the welcome message and given a link to the starter code. Now, in case if you get stuck with anything or if you're not able to understand anything, maybe post your question there, and then we'll try to answer your question as soon as possible.
Okay, so if there are no more questions, maybe we can close the session here. Thank you once again, Professor Arjunan, Pankaj, and Subodh for walking us through the models as well as the steps to run through the example code and solving the problems on Kaggle. We are looking forward to your submissions and having a good participation on the leaderboard during the course of this hackathon. Okay, and thank you everyone for joining today. Have a good evening.
Thank you and all the best. Thank you, everyone.